Hello, this is my PWM motor control circuit that I have in some of my other videos. I just wanted to explain some of the different boards and different components that I've used on here. Basically, I've built a DC power supply within here, and I'm using one of the 5-volt outputs to supply power to this keypad. And it lights this LED when I have power, and it also provides a wetting voltage to these tactile switches so that I can bring these button inputs to an digital input pin on my microcontroller. I'm using a Mega 328P, which is what the Arduino is based off of. And basically, I'll remove the LCD screen here, and all the microcontroller and most of the components are actually mounted on the back of this board. But basically, the other end of the ribbon cable is right here, and I have some 10K pull down resistors that I have mounted right there. Basically, whenever you bring an input into a digital circuit, you need pull down resistors so that the inputs don't float. They're very high impedance, and if you were to assert one of these buttons, it'll work correctly, but when you release the button, a lot of times it won't go down, or it'll act erratically, or sometimes you won't even push the button and the circuit will actually initiate if you don't have pull down resistors installed. And I've actually made these headers coming out of the back of the microcontroller where I can actually move pins around and reconfigure the circuit. Right here, this is actually the 12-volt regulator. It's a LM7812, and I'll spin this around so you can see the actual electronics back here. This chip right here is the Mega 328A, or 328P rather. This is a Max 485, RS485 TTL level signal converter. This is a Max 232, that's a RS232 to TTL level signal converter. This right here is a, I forget the model number, but it's a real-time clock. It's also made by Maxim. This right here is my programming header, and I use AVR Studio to program in C code. And basically, this header pin goes down and is actually wired back up through some of these connections to the programming pins and reset pin on the microcontroller. This circuit right here on the back, which is connected through this ribbon cable, is actually the output stage that actually drives, in this case, a motor. You could actually drive several different things. You could use it to run lighting, you could use it to run a heater. I mean, you could actually bring inputs back to this through the analog inputs on the microcontroller, do analog digital conversion, apply a scaling factor, and actually adjust for temperature. And you could actually run this output to run a heater to maintain a steady temperature, or you could have it run a fan speed control to cool things off. And I've got screw terminal outputs here. And the video, most of the time I'm actually using these 3 pins here, which are actually just paralleled with those 2 screw terminals. This right here is a very important component to have. That is actually just a diode, but it is hooked in reverse polarity. The cathode is actually hooked to the positive lead going out, and the anode is hooked to the negative lead. So it should be completely reverse biased. no current will flow through that diode. But is what happens when you drive an inductive load, any type of motor or coil. A lot of light bulbs are also inductive. You get something called counter EMF, counter electromotive force. It's almost a reflection from the load that actually comes back into the circuit, and it will destroy transistors. If you're using a contact, like actually just a not dry contact, but a relay contact, it can actually melt those contacts together. Most of the time your ratings on contacts are actually for resistive loads, which don't have any inductive element to them. But basically is what happens when that counter EMF comes back towards the circuit. It's in opposite polarity to the supply voltage, and it actually, in that case, the diode would be forward biased. So in effect it shunts the circuit to the counter EMF. It actually squelches that reflection and protects your transistors. These transistors would probably short within minutes. They would actually short out and be destroyed without having a protective diode like this. Over here I just have a 12 volt supply and filtering capacitor, and then I have just an indication LED to let me know that my driver board has power. And basically I'm using one of the outputs out of this at Mega 328 to actually supply PWM control signal to the base of these tip 41C NPN bipolar transistors.